So today our conversation discuss about graph material. I hope you guys enjoy this video. Hello, Barry.
Oh. Hello, Monica. How are you today?
I am great. How about you?
Good. Honestly, I have a little trouble with the material that I have to study.
Okay, so, what kind of subject do you want to study? Maybe I can help some.
It is about graph. I have no idea about it.
Wow. You were so lucky to meet me then. I know this material quite well.
Great. Can you explain it?
First of all, do you know what is graph?
No.
So, basically, the graph is a mathematical representation of a network, and it describes the relationship between lines and points. A graph consists of some points, and lines between them. The length of the lines and position of the points do not matter. Each object in a graph is called a node. A graph G is a set of vertex, called nodes V, which are connected by edges, called links E. Thus G equals V, E. Vertex, node, a node V is an intersection point of a graph.
Oh. What about the airline's route? As one of the model and graph.
So the airline route, as one of model and graph, this graph only models airports and routes. It does not attempt to model airlines, or route frequency. For example, the graph can tell you that there is a route between LHR and JFK that at least one airline operates. But, not which airlines fly that route, how many times a day the route is operated. That is exercise for another day and for a bigger graph. The graph also does not currently contain any aircraft information.
Wow! You are so great at this. So what about special graph?
Okay, special graph. I will explain it to you with some example of them. 1. The null graph. This graph has a V, G, which is non-empty, and a E, G, which is empty. In simple words, a graph which only has vertices and no edges is a null graph. 2. The regular graph. The graph G is a regular graph if all its vertices have the same degree. For example, if the degree of a vertex in G is R, then the graph G is said to be regular of degree R. 3. The bipartite graph. The graph G is said to be a bipartite graph if G, V, the vertex set can be divided into two subsets V1 and V2, such that if there exists an edge in the graph, it connects one vertex from each of the sets. Thoughts for special graph?
Very nice for the special graph. Now for the last time, may I ask you about plane graph? Please.
Okay, Barry, so the plane graph have 4 definition. The first one is a graph G, V, E is called plane if V is a set of points in the plane, E is a set of curves in the plane such that 1. Every curve contains at most 2 vertices and these vertices are the ends of the curve. 2. The intersection of every 2 curves is either empty, or 1, or 2 vertices of the graph. The second one is a graph is called planar if it is isomorphic to a plane graph. The plane graph which is isomorphic to a given planar graph G is said to be embedded in the plane. A plane graph isomorphic to G is scaled its drawing. The third one is a set U in a plane is called open if for every x element of U, all points within some distance r from x belong to U. A region is an open set U which contains polygonal U, V curve for every 2 points U, V element of U, and the last one is given a plane graph G, V, E, a face of G is a maximal region of the plane if the vertices and the edges of G are removed. An unbounded, infinite face of G is called exterior, or outer face. The vertices and the edges of G that are incident with a face F form the boundary of F.
Wow! Thanks a lot, Monica. You are very helpful.
My pleasure, Barry.